Hey everyone, in this presentation, I want to talk about uh, how to read an empirical piece, in particular, this piece by Oneal and Russett from 1997. The classical liberals were right. Democracy, Interdependence, and Conflict, 1950 to 1985. ISQ, blah, 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 blah. And so the point in this is I'm not trying to present the full results. That's left to the students here. What I'm going to try to do is say, okay, here's what they're saying, and trying to point out how you read the paper and kind of help you to read it in with an eye towards how do you read empirical papers in general. Okay, for reading empirical papers, at first they're hard. Eventually, once you get used to them, they're actually very easy because they follow a set predictable pattern. You kind of it's kind of like normal science, right? We understand what the methodology is, and you know your familiarity with it just kind of moves you forward, right? So how do you do it when you confront one of these papers? You're like, okay, what's the theory and hypothesis? Also, I mean, obviously you're interested in what's the dependent variable, what are they trying to explain? But all empirical papers are going to tell you the theories, right? There are theories that identify independent variables, right? You start out, the researchers are interested in the dependent variable because that's what they're interested in. And they're going to look at theories and talk to you in their literature review. And it may not be listed literature review. It'll just be a talk of, okay, what are the theories at, that explain this dependent variable? And those theories generate hypotheses, right? That is to say, they predict relationships between observable phenomena, right? So in democratic peace, they predict that democracies will not fight one another, right? And so that becomes a hypothesis, right? That this is an observable thing we can go out and look at. Okay, so you get that. Those are the words, right? Basically, this question is answered by reading the first part, the words of the paper, and then you'll get into a period where it's basically the introduction, right? They introduce the topic, they give you the lit review, and it may not be called a lit review. They may just be looking at the different theories that are out there. Then they'll get down to business and say, okay, here's what we're going to do, and they will lay out their research design. In this paper, there's actually a section called research design. It's not usually named that, right? But it's very often in there, where they'd say, okay, here's what we're going to do. And in that section, they're going to define the variables, right? And so this is the big thing. When you're reading this paper, you're like, okay, I got an idea. Here are the theories. Now, what are the variables, right? Because that's what theories do. They point out the independent variables. And when I say what are the variables, I mean the independent variables. Although, we do want to know how they're going to measure things, right? So when looking at variables, we want to know conceptually how they're defined, and then practically, how have they been measured? What's the data here that you're using? And you're going to have the dependent variable and a bunch of independent variables identified by the theory. So you really need to know what they are. And very often this is, there will be little labels associated. When working on these papers, you tend to create a name. And if you're a lot of the programs that you use require, they all require you to assign a name. And so you have a string of letters usually that are not complete words that you use as labels for these things that end up getting in the paper. And so it's not a trivial question, right? What are the variables? Because it's also, well, what does contig mean? And what does deml, dem sub L? And we get a lot of subscripts, and, so the notation is often off-putting. If you're not familiar with mathematical notation, it can be a bit off-putting until you get used to it. So you need to, when consuming one of these papers, you got to go in and say, okay, what are the variables? And then there's like, okay, once you have the variables, what are the results? And the question here is, what are the models tested? And a model means a combination of independent variables, because most empirical work is going to have multiple independent variables. They're going to have, there's going to be multivariate regression in one form or another. Very seldom do we simply test the effect of one variable on something, because even if we're testing the effect of that variable, there are other variables we might need to control for, right? For instance, big one, if you want to see whether being a democracy makes you go to, whether democracy is going to go to war with one another, you probably want to consider, well, how likely is it that, all things being equal, these two nations, regardless of their type, might go to war? Meaning, one of the big things is contiguity, right? I mean, if you find that Peru and Thailand don't go to war, well, duh, Peru and Thailand are not likely to fight. Neither is Thailand and Nigeria, because they're small nations very far apart, right? Why would they fight? Now Thailand and Cambodia, or Thailand and Myanmar, I mean, that's another story now, isn't it? Similarly, Peru and Chile, and there's a question: why would they? Maybe they would, the countries around them are far more likely candidates. So contiguity would be a control variable, right? You would throw it in there to kind of get, this is another thing that makes a difference. So this is when we say, hey, I'm going to add this in, we're talking about a model, right? Once you start specifying, and this is generally the term, specifying which variables are included, you are laying out a model. So you're going to see in almost every paper a model with a number of variables, and you're going to see multiple models tested, right? There will be, sometimes they will define variables in different ways. Sometimes they will add a variable in and see, because you can then say, okay, what's the effect of adding this in, right? And so you will have different combinations of independent variables that are tested, right? And each of those is a model. So you want to know what the models are, and generally that's just, they're in a table, and it's the things that are filled in are being tested at any given time. And then once you understand what's going on there, it's a simple thing. What variables are actually significant, and are they, is the relationship that's observed between the variable, the independent variable, and the dependent variable? First, you want to know, is it significant? Is it statistically significant? Is it large enough in comparison to the randomness or the variation or the error that you get in the data, that it, the fact we're seeing it is it's unlikely to occur randomly, right? That's basically statistical significance. And so if a variable isn't significant, we say, well, we can't reject the null hypothesis that any relationship is just randomness, right? So we want to know what variables are significant in what models, and sometimes we'll compare across models to see what happens when you add a variable in or take one out. And these are the results, and they're almost always presented in a table, right? And so we're going to talk about that. Then that's the big thing. And then at the end of it, once you get those results, you look at the author's conclusions and go, okay, why are they saying what they're saying? What do they make of the results? Because remember, the results are facts, right? If you follow what these guys did and say, all right, they've defined their variables this way and defined it that way, this is the result they got. That becomes like a fact, right? That's just, hey, this is what we observed, and we've done a statistical test, and these are the results. However, that's not a conclusion, right? The conclusion is what you make of those results, how you interpret them, what inferences you get from the fact that this variable is significant here in one model and not in another, or significant in all models, or is not significant, right? What do you make out of that? The authors will give you their story. Then the question, the bigger problem, a thing that, and this kind of, in life, what do you make of the results, right? Remember, the results are facts, right? The results are what I call the hard kernel of empirical truth. This relationship has been found. Do you have an alternate explanation for that relationship? Right? You can make a different argument, or you can draw different conclusions. You can, that's what's cool about empirical work, is that it's open. You can look at it and go, all right, what about this? And this is how you do other papers. But so my thing is that, the authors are going to make tentative inferences. Their inferences are always going to be couched in very tentative terms because we're not sure, right? They are inferences. And it's sometimes non-academics don't like the tentative nature of the conclusions, but they are going to be tentative. And they're going to, be kind of seem mealy-mouthed, but they are they are making an inferential leap from their results to a conclusion, and you have to say, all right, what do I think about that? Is that good? Whatever. All right, so those are the basics. Now, in the Oneal and Russett paper, they have a whole bunch, and I'm not going to go through every single thing here. I'm going to tell you what you should do. And these guys in this paper, they lay things out in ways that is not common. They almost lay them out in a pedantic way. They have a long definition. They have a lot of text. They talk about each variable, right? In that section, they go, okay, hey, research design. We're going to do logistic regression. Okay, what's logistic regression? Most regression, right? Ordinary regression. In fact, we call it ordinary least squares. Right? That's the basic kind of regression that everyone does. That's why they call it ordinary, or OLS. Needs to have, the dependent variable in that needs to be what we call interval level data, a number, right? So we could talk about trying to predict the percentage growth of an economy, or the overall GDP of a nation in millions of dollars, right? That's a number that varies, and it's got, well, it's a number, right? The dependent variable here is dispute, right? Do disputes occur, right? Which they say as a threat, display, use of force, or war, right? So they're going to give it a broad definition, dispute. But the thing is, it's a dichotomous variable. It's either a 1 if there is a dispute, or a 0 if it's not. That they call it dichotomous variable. We can also talk about categorical variables. Of course, you can have more than one category. Categorical variables, small, medium, and large, right? Republican, Democrat, Independent. Those are categorical variables. And you need to do a different type of regression. Logistic regression and probit regression are both just different techniques to predict a dichotomous dependent variable. Right? And like I say, this is stuff you got to know. But so when they say they're going to do a logistic regression, no big deal. Okay. Then they have all the other variables, right? And they explain in nauseating detail how they define, democracy. They use a rating of it from a data, and a lot of research goes this way. We use a rating of democracy from one database. We use whether or not there's a dispute from the correlates of war database, right? We use, they have to explain for each variable how they do that, and they do that, right? They have, but here they provide a table that, normally you don't get this, right? Normally you don't get the table that tells you so handily what they are. Of course, to understand exactly how they're measuring each one of these things, you have to go in and read the section to say, all right, and they have a big thing like, they also have they have democracy lower, democracy higher. Now, what they're doing is they're doing dyads, right, which you should be familiar with from previous weeks. They're looking at combinations of nations, and so in the database in each year, and they also have time, right? They have, in this year, right? Usually I believe it's years. They have, do we have a war between Chile and Thailand, right? And that's a dyad. And also Chile and Peru, and Chile and the United States, and Chile and Germany. And, what we're, all combinations are dyads, right? And yeah, when you consider all dyads in all years, you end up with a crap ton of dyads, right? And the question is, so when they talk about democracy, they kind of have a joint issue going on, right? What's the pair? And so they have dem sub L, which is the democracy rating of the lowest in the dyad, the lowest democracy rating, right? And then they have dem H, which is the highest one, right? So how are you going to characterize the democracy level in this dyad? Well, it's a question of, they have two measures. They have two ways of doing it. One is to look at the lowest common, the lowest rating in the pair, or the highest rating. Economic growth, they have a whole thing, right? They talk about, what's it's growth sub L, what's the lowest rate of growth in the dyad, right? And there, to understand why they're doing it, though, you have to go back to the theory, right? They say, look, the theory is that states that are growing well are happy with the system and don't want to upset the cart, right? This is an economic liberal concept. And so they're like, all right, so in a dyad, the tendency to war is going to be driven by the least satisfied one, right? That's the idea. So the one with the lowest rate is going to be, it's the lowest common denominator, right? They're at least growing this fast, right? And so there you go. Allies. Are they allied with one another? Allied with the U.S. Contiguity, right? Indicate. And so you have all of these different things that you kind of have to go and say, all right, what are these things? How are they measured? Do I have a basic idea of what they're doing here? And keep in mind that every variable is always associated with a theory. There's a theory that produces a hypothesis, like I was talking about with the growth, right? So we're going to have a prediction in there, implicit in all of this, of what we should see, right? We have a theoretical prediction of what should the relationship between this variable and the dependent variable be, right? And so all of that is what you do in that first thing. And like I say, here they have a nice little table, gives you a cheat sheet. A lot of papers will just go through the defining and how they're measuring each variable in the research design, right? And in the research design, the focus is, is not so much on the theory. The theory should have been established before the research design of why growth is there but there will be a reference back to it, right? But in the research design, they will get into the mechanics of what data we're using, how are we measuring interdependence, right? And it's exports and imports from one country to another divided by that country's GDP, and so you have a number for both of them, right? And that's why they have low and high, right? In these things. So all of that, that is discussed in nauseating detail in the research design. Then you get to something that looks like this awful thing, right? Where you have and this is known as the specification of the model. And this is where they write out an equation that tells you what variables they're going to use, what independent variables they are going to use to, what they're going to test, right? So it starts out with the dependent variable, dispute, sub ij at time t. What? All right, just reading the notation, that's a dispute. We have I and j are used to refer to the two nations, right? There's nation I and nation j in the dyad, and t is the time, right? So, is there a dispute between Peru and Chile in 1955, right? That would be one dyad, right? And so that's the ij comma t subscript, right? So that's your dependent variable, and that's always, and then it equals, right? There's an equation because the computer's going to try to create an equation to take the variables to equal, dispute, right? And dispute's going to be a 0 or a 1, right? If there's dispute, it's 1. If it's not, 0. Then what you get is all these b's, right? Betas and B's are used as the coefficients, right? These are the things, and it's the B's, B naught, which is your intercept, and it's an equation for a line in 5-dimensional space, which is weird, right? But it theoretically exists. But each of those is a coefficient, like the slope of a line, and the B naught is the y-intercept, right? Where if everything is 0, this is what what it should be, right? It's the constant, the intercept. You always have that. Sometimes it's meaningful, and sometimes it's not, right? But it's there, and we kind of just gloss over it because we're used to it. Then you got B1 dem times dem LT, right? Which means B1 is the coefficient, and the B1 that's what the frickin' computer's going to find out. Dem L is democracy lowest at times T, right? So it's the lowest level of democracy in this dyad, IJ, at time T, right? And so that's the democracy level, right? Then B2 is growth level. Again, lowest of the two in time T. And then B3, right, is times, it is allies, whether there's an alliance or not, right? And the point is that all it is saying, look, we're going to look at whether democracy, growth, allies, contiguity, capability ratio, which is the balance of power, right? Because they're putting realism in here, right? They're keeping that idea that, hey, maybe power is important. And then the level of dependency, right? And they've got all of these factors in here. And basically, they're just saying, look, we're going to run a model that's going to test all of these independent variables to try to explain dispute. And the B's 1, 2, 3, 4. I don't know why there's a B sub S. It should be B5 and 6. The point, though, is that we're going to, that might be a typo from copying it. But the point about the specification model is when you break it down, it looks fancy. It really isn't. It's just like, okay, these are the independent variables that we're going to do. And yeah, all these B's, the coefficients, well, that's what the computer's going to find out, right? That's what it's going to see. What is the the computer's going to use regression to try to say, what is the observed relationship between this independent variable and the dependent variable? And so that's what we're interested in finding. Okay, those results, once you have that, you end up with a table. And I'm going to break this, I'm going to zoom in on parts of this table. But essentially, you have each separate, these are the lines for each separate variable, right, that's in there. Remember, the dependent variable, it's all the same, right? It's whether or not there's a dispute. And here are all the independent variables. Then down here we have the constant term. And then we have some things like chi-squared, which, and I'll talk about these things later. And then the n, the number of observations, right? And in each of these things, we have entries, right? And the key thing is the B, the beta, right? The coefficient. That's the primary thing. And so they're all listed here, and I'm going to zoom in on this. That'll be better. But also, kind of taking the overview, each column is a different model, right? And so in the first, right, or here they have equation 1, right? And so in the first column, we're seeing the results of when they run their regression with democracy, economic growth rate, allies, contiguity, capability ratio, and dyadic trade to GDP ratio. And then see, we have these blank areas here. That means there are two other variables or ways of measuring them that were not included, right? So this is basically one model being tested. Then right next to it, we have another model. And you just don't, if you step back from it, you can see there's a gap here and there's results here. So basically in the second model, they replace the dyadic trade to GDP ratio with the total trade to GDP ratio, right? And then they have both of them. And then they drop one out. And so we have different, basically what they're doing is they're looking at each model uses a different variable or combination of variables to look at trade to GDP ratios, right? And all of that is measuring interdependence. So they're looking at basically what changes from column to column is the way they measure interdependence, right? Because there's different ways to do it, and they're looking at all of them. And you try to say, hey, does the way I have, what they're seeing is, hey, does changing the way we measure it affect the results? We call, and this is about robustness, right? If a result stays the same, even when you make minor changes to how you measure it, it's robust. If it's not, well, it's not robust, right? Okay, so that's kind of the overview. This is what you're seeing in this table. Let's zoom in a bit. Okay, looking at the top here, what we've got is, and you're not going to see this. This is not standard, right? What is standard when we do this sort of thing is that you have the beta, right? This is the coefficient for democracy, right? It's negative, meaning that a higher democracy score is less associated with a lower likelihood of a dispute occurring, right? So that's that is the predicted direction. Now the question is, all right, what's wipe out that. The next entry is the standard error, right? Now this is always reported below the coefficient, or it should be. It almost always is. Very often the convention is that it will be reported in parentheses. And there is not a substantive interpretation to it. And in fact, the important thing is the frickin' B, right? The beta, right? Is there a relationship? What's the, how strong is it? What direction is it? The standard error relates to, well, how much variation is there in this, right? And the ratio of B or beta or whatever the coefficient is to the standard error is used, and they do mathy, they do math. The computer does it for you to figure out the P, right? And normally, right, this P number is not expressed this way. This is what's weird. These guys are, one, they're freaking labeling these things. Normally it's just assumed you know what they're doing. And they're also showing for each variable the probability. What's this probability? This is the probability that the relationship observed could be the result of randomness, right? And so low P's are good, right? This is about statistical significance. Now, normally, these things are not given the way they're given here, right? And so in some ways, this is good because this is, they're labeling, they're at least telling you what each thing is. And, so for you guys, this is maybe good, or for new students, that is, right? But it's not the normal way. The normal way is that when you have a low p-value, you put asterisks by the coefficient, right? That's the standard way of designating. And so where there are asterisks, it's significant. More asterisks means significant at an increase, the P is smaller, right? No asterisks, not significant. And generally the standard error is reported because you can just, a lot of people, when they get used to doing these things, the asterisks are, the asterisks tell you kind of in lumpy terms, hey, is this significant or not? You can look at the ratio of the beta to the standard error and get a sense of how it is. So point is that normally you just go on an asterisk hunt. Here we're going to have to look at these things and say, all right, what's the p-value associated with it? And you'll notice that if we go around, right, all of these p-values, what we're looking for, the standard is that, if you talk about a 95% confidence interval, P has to be less than or equal to 0.05. So all of these are significantly, even economic growth, at 0.009, well, that's a hell of a lot less than 0.05. All of them are, in fact, significant. And indeed, looking at all across the models, right, the lowest p-value is here at 0.02. I don't know if you saw, I just in equation 6, economic growth rate, even that is significant, right? So they found that all of these things, and normally there'd be asterisks freaking everywhere, and I was called, looking at the results, an asterisk hunt. Right? Here we don't have asterisks, but the point is, though, the larger point is that, well, are things, in the right relationship? Are things happening in the predicted way? And in general, yeah, things are doing what's predicted. And this is the thing of like, look, are these results? Now, we got to really look at capability ratio, right? That's the realist. Keep in mind that the capability ratios, right there, that's the realist explanation. And we got to look back, all right, what's that mean? That's all significant. The key thing is, do the realists need, do they need to be right? They don't need to be wrong, right? For democratic peace to be right. Because that's, by the way, that is the overarching conclusion, is that, hey, when we look at all this, it's all, negatively associated, So this is how you do it, and this is what they're doing, and I hope that demystifying this stuff kind of helps. Now, just I know this has gone 30 minutes now. At the bottom of the table, there are some things, right? And again, we have the other at the top of the bottom here. We have the other trailing variables, right? The key things I want to talk about, though, we have the constant that's reported, and constants do have significance. Right? Is there anything here, right? In terms of is there a meaning, substantive interpretation to what the prediction would be when everything was zero? Well, with democracy scores and trade, and they're almost never all zero, right? So it's not a meaningful. Basically, a lot of times you ignore the constant, right? But they report it, right? Chi-squared. Let me look at, point out a couple other things. One, this chi-squared thing. This is for the whole model, and that is a calculation of what are the odds that the model, the overall, the whole thing is capturing something or just seeing randomness. And you'll notice very low numbers for the chi-squared, right? In ordinary least squares in regressions that aren't logistic or probit in nature, you'll often see an R-squared there. These are what are called goodness of fit measures, okay? And they talk about the whole model, right? How it does. Not a lot to it, though. There's not with these things. There's not a thing. And there's also this log. Oops, hang on. There's also a log likelihood number that's in there, and again, that's another goodness of fit statistic. Not really. They're notoriously hard to interpret for logistic regression. So basically, okay, look at that. Yeah, oh, wow, look at those numbers. Great, okay, move on. Also, one thing that is interesting perhaps is the ends, right? How many of these things they actually have, and it's a lot, right? There's 20,000 here, then 17,709. Why the difference in numbers? Probably missing data, right? That they're missing data on a bunch of dyads because there's different variables involved, and so they're probably missing data for when they're doing the total trade to GDP ratio, so they have a few thousand less. But this is a lot. 20,000, I mean, basically 21,000 dyads is a lot, right? But silicon's cheap, right? Computers, they don't mind. They'll crunch the numbers. My point though is, hey, look, and you can complain about the fact that, hey, they only look from 1950 to 1985 because that's when their data availability is always a nightmare for people. And they're like, well, that's just that time period. Yeah, okay. Still 20,000 observations in it. And all nations are included. You're not cherry picking. You're not anecdotally arguing things. You're looking at all things. However, there is, you can, one of the complaints about this that students frequently have is, hey, look, it's only looking at a very narrow period of time, the post-Cold War era. What about after that? And, what about before that? And, well, this is the data that's available consistently to measure. I will tell you, by the way, that other people have had similar confirming results, and so these guys have not been overcome, but just keep that in mind. But the big thing I want to point is okay, there's your table, there's what you do. Now that they go on and do some other models in the paper, and so you'll have to apply kind of the steps I have here, but this is how you read an empirical paper like this. And hopefully this has demystified it a little bit and will help you to, I just really don't want, you can't open up an empirical paper and do a Homer Simpson, and drop it, and close it. Like, oh, look, there's math. If you know what they're doing, you can kind of, there might be some technical blah, blah, blah. But, you can, if you kind of understand what's going on, you can get a sense of, well, what are they doing? And get, say, all right, what's the result here? What are they finding? And you can benefit from it. And so there's something, until you take the methods course and get deeper into this stuff, hopefully this will, tide you until then.